Light. Uh, Name of this lecture is what light. Uh, Standard is Earth, and my name is here. As you can see, my name is written here. And about light, as you can see, bulb. It is giving you a idea that yes, about bulb in details we are going to understand. Apart from this bulb, we will be exploring something else which will be related to this. Okay. For example, filament. Filament is inside bulb. Let's just see what's in this lecture. Okay, name of this lecture is what light. Yeah. Now next, introduction of light. Light is a form of energy that enables us to see objects. Hmm. Now I ask you, how do you see any object? How do you see any object? This is my question from my side. This is question from my side. How do you see? How are you able to see to me? Tell me. How are you able to see? Your answer would be because of light, isn't it? You would say, sir, I am able to see you because of light. Light. Yes. We can expand. We can expand this. We can expand how are we able to see any objects. Remember, mm, we can see surrounding us there is a light. It can be sunlight, it can be artificial light. Okay, when it will come to artificial light, it means those lights which are made by human. Nature lights which are made by nature. For example, sun, stars, all these are nature lights. Artificial light, bulb, torch light, LED, all these are artificial light which were made by human. Now here, surrounding you, you can observe what there are a lot of there is a sunlight which is giving us light, and those lights are falling on objects. That's why you are able to see. When those lights will fall on the surface of object, then it will turn into another direction. It will turn into another direction. Some lights will reach to your eyes. Then this process is how how are we how we are able to see. Clear? Clear? Yes. So uh, light uh, gives uh, light gives a view to see anything. Okay. Light is a form of energy that enables us to see objects. Also remember, light will travel in a straight line. It does not travel in zigzag, in this, in that. No, it will travel in a straight direction. In a straight direction. It is a fact. Clear. As you can see, in front of is a bulb, and light will this bulb will emit light. Okay, when this bulb will emit light, of course light will come like this, like this, like this. So these are direction of light, and direction of this light is in a straight line. In a straight line. Okay, in a straight line. All these lights are coming from this bulb, from this bulb. And some lights will fall on surface, then it will turn into another direction if object is bugged. Okay, right now I am saying all things. Okay, so here first is what light will travel in a straight direction. It travels in a straight direction. It does not travel like this. Clear? It behaves like a ray when interacting with the surface. Here from this figure, as you can see before this, let me explain about this. In recent time, this type of bulb used to use, but now A lot of people don't use this type of bulb in their home because of reason was very big. What this bulb was consuming a lot of electricity, as well as it was consuming a lot of yes, it was consuming a lot of electricity, but it was also providing more heat. That's why it was replaced. That's why this type of bulb was replaced with another bulb, and today we are using a lot of bulb does not which does not provide heat, which does not consume more electricity. And those lights are what mercury LED bulb. These are those bulbs, and these are those bulbs brought because of this bulb. This bulb was consuming a lot of electricity, as well as it was providing a lot of heat. That's why it was replaced with a new bulb, which is LED, mercury, all this. Okay, all this bulb. Clear? Now inside this bulb is okay. Hold on. Yes, here I would like to explain about functions of this bulb. uh, this inside this is what wire of black wire, red wire, and here these two wires are connected with the two terminals of this bulb. One will be added with here, and one will be added with the base contact of this bulb. Now here inside this you can see there is what thin wire. I am saying thin wire, which is a necked wire. Okay, which is a necked wire. And here, just here, you will observe what a filament wire, which is a necked wire. It is very thin, and that's why this bulb glows because of a thin wire, because of a thickness. Thickness is very low. That's why yeah, that's why it glows here rather than here. Okay, it glows here. It is not a necked wire. It is a covered by plastic. But here, as you can see here, it is not covered by anything. That's why it is glowing. And here we can see what this is thin. This is thin. Filament will be thin. It is a covered. And here is what that is where the bulb glows. Okay, bulb glows when all things, connection of all wires are correct. Then clear. So filament is where bulb glows. Clear. And filament is curved. It is thin, as well as it is necked wire. That's why it glows. Okay, this transparent object, you can see it is what bulb glass. It is a transparent. That's why light can travel through this transparent object, because it is a transparent object. That's why light is able to travel through this glass bulb object. Clear? But here you will see what this light will not travel through this plastic material, because of it is not a transparent object. That's why. So here now, let's understand about this figure. Here we have two torches. One is, and mm, here this light is coming from this torch, as well as light is also coming from this torch. Now we have four cards in this. Yes, we have four cards, as well as in this case we have also four cards. Here you can see each in first case you can see each cards has a hole, has one hole. But in this case only three cards have holes, but one card does not have a hole. Now what will happen? Let's see. Torch is giving light is coming from this torch, like this. Okay, here you can see light is traveling. It is traveling in straight direction, isn't it? Of course it is traveling. This light which is coming from this torch is traveling in this direction, and it is a proof that light travels in straight direction. So this was explanation practically. Okay, in this figure you can see In this figure you can see light will come from this torch. It will go like this, like this, like this. But here this light will not pass this card, because of this card does not have a hole. That's why. And it is a opaque object, which means a object which does not allow to pass the light. It blocks the light. That type of object will be considered as a opaque object. Any object which is not allowing to pass the light, that object will be considered as a opaque object. Clear. So in this from this figure we understood that yes, light will travel in a straight direction. That is what we understood in this. And we can also understand if light there are three types of objects. First is a transparent object. So always remember, a transparent objects are objects which allow the light to pass through them. Okay, through them. uh, a object will allow to pass the light. That object will not block at all. Here you can see this glass bulb is a transparent. It is allowing to pass this light which is coming from filament. It will not block the light. Okay, this type of objects are considered as a transparent object. And one another object, uh, opaque object. Opaque object. Opaque object, I have hold on. Opaque object, this board, I have this object. It is also object. Now light will come from source light, will hit on the subject, but it will not allow to pass the light which is coming from source light. And it will block it. This type of object will block the light. And when it will block, it means this when light will fall on the subject, on the surface of this object, then it will turn into another direction. It can turn into in this direction, or in this direction. Okay, it depends on light. It will depend on what is the direction of light. Clear? What is the direction of light? So remember, any objects which is blocking the light will be considered as a opaque object. Translucent objects are those objects which has what, some blur, glasses, and some area which can block, which blocks what, which blocks uh, which blocks mm, which blocks the light. Okay. Translucent, there are a lot of translucent objects in our world. In our world, uh, translucent object, a object will be blocking some lights, but some area on that object will not be able to block the lights which will be coming from source light. And both will be happening with the one object. That object will be considered as a translucent object. That's it in this slide. Now next, laws of reflection. These are rules, these are laws. Okay, we cannot manipulate these laws of reflection. change we cannot change laws of reflection. It will happen, sure, it will happen. 100% is a chance that it will happen. First law says that angle of incidence, this angle, okay, this angle of hold on, yes, incidence, which means a ray light which is coming from source light till the surface, from here to till here. This ray light is incidence light, incident light, okay, incident light. And this is angle from this incident ray till the normal line is a incidence angle, is a incidence angle, clear? And a light which is a ray light which is from the surface till the infinite, till the another surface, okay. A ray light which is coming from surface, which is coming after hitting from surface, will be considered as a reflected ray, will be considered as a reflected ray. That's it, okay. So from the reflected ray till the normal is a reflection, the angle of reflection. This is a reflection angle, this is the angle of a reflection. And we take a normal line to consider angle, that's why we take normal line, okay. It is an imaginary line, clear? So here we have a surface which is a straight line. When it comes to a straight line, you know what would be and what would be angle. Angle would be 180 degree because of it is a straight angle. Now we have a normal line, it is perpendicular to the surface, that's why we can say this side is 90 degree, this side is making how much, with how much degree, 90 degree, and this side is 90 degree. So sum of this and this would be 180 degree, that's why. So as you know, this perpendicular is what, 90 degree, clear? 90 degree. So first law says this one incidence ray will, angle of this incidence ray will be equal to this. I am not saying from here to till here, I am saying from this incidence ray to the normal line will be equal to this line, which is from normal line to the reflected ray. This both will be equal to this both will be equal to each other, okay. Let's say angle of this incidence ray from here to till here is a 45 degrees, so same here angle would be 45 degree. It is a first law of a reflection, okay. It will happen. Clear? So if this is equal to this, then of course this will be equal to this will be equal to this, clear? Okay. Now next law, the incidence ray, this incidence ray and the normal line, this normal line in the same planes, reflected ray and normal line will lie in same plane. All these three, as you can see, all these three are lying on same plane, okay. A reflection follows these laws on all surface, a smooth or rough, a smooth or rough. It doesn't matter surface of the object is rough or smooth. It doesn't matter. These laws of reflection will be followed on this surface, which is surface is a smooth or rough. Okay. Now next is the types of reflection. Let's explain it. What does it say? Types of reflection we are understanding. It is also important to understand. We cannot ignore it at all. First is a regular reflection. Regular reflection, which means parallel lines, parallel rays. Angle of a parallel rays will be equal to uh, angle of a parallel reflected ray. Angle of a parallel incidence rays will be equal to angle of a parallel reflected ray. Occurs on a smooth surface like mirrors produce a clear image. Produce clear image. Of course, yes, because of it is happening on a smooth surface. That's why you will get a clear image. Here, reflected rays. These are parallel lines, and these are parallel reflected rays. These are parallel incidence ray, and these are parallel reflected rays. We have a regular reflection, it will happen, regular reflection will happen on a smooth surface, okay, on a smooth surface, clear? Now you can see angle of this ray is equal to angle of this. Clear? So that's why I am saying angle of a parallel incident ray will be equal to angle of reflected ray. Clear? Now next is a diffuse reflection. It means a direction. A direction of some rays will be this side, will be this side, and it is happening because of osmosis, because of a surface is rays rough. That's why it is happening. Okay, diffuse reflection will happen if surface is rough. Then it will happen. Clear? Then it will happen. What else? What else? Here you can see we have this reflected rays and we have this reflected rays. Here you can see rough is surface is rough. That's why uh, here you can see. So here normal line will be like this. Normal line will be like this. Here we will be following the same laws of reflection. Okay, in this diffuse reflection, laws will not be changed. Okay, for this diffuse reflection, laws will be same as we saw laws of a reflection ray. Okay, because you can see a normal line, when normal line will be like this, according to this normal line will be like this. Of course this angle will be equal to this angle. Now we have incident ray, normal line, one more which is a reflected ray, and all this is on surface, and it is what for a second of reflection. Clear? So always remember, regular reflection will occur on a smooth surfaces like a mirror. It will produce a clear image. Diffuse reflection will happen on surface reflection because it is reflected rays. It will happen. Just remember, it will happen on a rough surface. It does not provide a clear image. Okay, a clear image. Next, we are moving towards the next. Now we have a plane mirror and its characteristics. Okay. We don't have a plane mirror, which means surface is a smooth. Okay, a surface is not rough. Surface is a plane. Surface is a plane. We will understand what are characteristics of a plane mirror. Let's see. If we have a plane mirror, so of course, before I look on the explanation of this book language, I would like to explain from my side. Uh, Plane mirror will give you what will give you uh, this same image as original image. Okay, if you are in front of mirror, then same image will be appearing inside the mirror. This is the first characteristics of a plane mirror. Now second, distance from original object till the mirror will be same as distance of image which is inside from the plane from the mirror will be equal. So distance, both distances will be equal. This is what I am trying to tell now. Yes, we are able to observe what a duplicate image which is inside a mirror. So of course, this will be considered as a virtual image because of the image is not a real. That's why image is inside mirror. Image is inside mirror. So this type of mirror, this type of image will be considered as what virtual and erect. So here we are saying erect. What is the meaning of erect? Meaning of erect straight. Nothing is a change. Nothing is a change. Straight. Okay. Erect. Uh, Size, you can say size will be same. Size of an object will be same as a size of uh, original object is same. Okay, for example, image of original object is size of original object is 10 centimeters, so 10 inch, 5 inch, let's say 5 inch. Size of original object is a 5 inch, so size of image will be same. It is a meaning of a erect, same size as the object, same size as the object, nothing laterally inverted. It means laterally inverted, which means if you are in front of a mirror, and in your shirt is written something, in your shirt is written something, those letters will be will be looking strangers, inside the mirror. This is a difference, and this is called laterally inverted. If letters which is written in your shirt is looking inside the mirror, which is in state, which is in stranger, so this view is called laterally inverted. So it will happen with the letters, only with letters. Clear? Appears at the same distance behind the mirror as the object is in front of you. It is telling you, let's say distance of original object till the mirror is 5 5 meter, 5 meter. Then same a distance between a plane mirror till the image will be same 5 meter. Okay, 5 meter. Clear? That's next. Multiple reflection. Multiple reflection. How will it happen? How will it happen? Multiple reflections happen when we have more mirrors. When we have more mirrors, then when uh, when when a light is falling on a lot of objects after reflecting. Here, when light reflects more than one twist or two mirrors, one twist more than one between two mirrors. Used in devices like periscopes, kaleidoscopes. These are devices which are used as to see, which are used to see view from stranger place. Here, this person wants to see this tree from here. It is not directly saying, it is not directly watching this tree, but by using this device, it is able to see this object because of in this device here is a mirror and here is a mirror. Now light is going in this direction, which is in straight direction. It will hit on this mirror, then it will reflect. This is an incidence ray, and it will hit some direction of some lights will go in this direction, and it will hit on this surface, of course on this mirror, then it will turn into this direction. These are reflections. Only this was a reflected ray. It hit on this plane mirror, then it went in this direction. Then, it hit on this mirror, then it uh, it went it hit on the surface of the tree. That is how he was able to see the tree. Clear? This is a figure of will a reflection how will a reflection happen. Now we have this device. Our eye is here, and this is one mirror, and this is one mirror. This is one mirror, this is one mirror, and we have this object. Clear? This object. Here, what will happen? Light will go like this, like this, like this, and we will be able to see what we will be able to see object which will be here. This object will be appearing on this plane mirror, and also on this plane mirror. Our eyes is here. Our eyes will look inside this mirror, and we will be able to see this object. And here object is here, and we are able to see object inside this mirror because of light is going like this. It hit on this on the surface of the mirror, then it hit on the surface of this mirror, and like this, uh, like this. Okay, it hit on this on the surface of this object. Really. Next, dispersion of light. Dispersion of light. Dispersion, which means light is going in this splitting of light. Dispersion, which means a splitting of light. Dispersion, a splitting of a white light into seven colors. In this context, dispersion, which means a splitting of white light, and white light will give you seven lights, except white light. And seven lights are violet, indigo, blue, green, yellow, orange, red. Here we have white light. Here we have white light, and white light is falling on this prism. It is splitting this white light into seven, and those seven lights are here, as you can see. And intensity of red is high, and intensity of violet is low. Is low. So always remember, white light has seven colors. White light has seven colors, and those lights are what? Those lights are these. Clear? Hmm. Dispersion, which means a splitting of in this concept. Dispersion, which means a splitting of seven lights from one color. It happens when light passes through a prism. If you wanted to see seven lights from a only white light, then you will have to use a device which name is a prism. Just put a prism in front of you and take a white light, and just that light will let off fall on that light will let fall on the prism. Then it will give you seven lights into dispersion. Discovered by Isaac Newton. It was discovered by Isaac Newton. Okay, I am moving forward. Human eye and light. We are going to explore in structure of a human, function of parts of a human eye. When light will reach to our eyes, then what will happen to our eyes? Light enters into eyes, then it passes through a cornea. First surface is what transparent layer. First surface of our eye is a transparent layer, which allows to pass the light inside our eyes, pass through a cornea and lens. Then after transparent layer, we have cornea. Okay, we have cornea. Transparent layer is a cornea and a lens. Then we have a lens. We have lens. It will go through our lens, so that image can be observed on the retina. So when light will enter into our eyes, then it will pass through cornea and lens. Then image will be formed on a retina. The eye lens is a convex lens in shape. Yes, naturally, in human eye, a lens is found which is a convex lens. Clear? Retina converts light into electrical signals for the brain. Retina. So where is the retina? Retina is here, and it will convert light into when light will reach to the retina. Then it will work of retina is to convert light into electrical signals, it can go so that it can be sent to our brain. then our brain will say yes, the name of this object is this is image, this is image. Okay, so that's how it works. That's how our human eye works. Here you can see we have cornea, then iris. Iris is what, around a white, around a white, is a what, different color. Sometimes it can be black, it can be brown. So color of iris, color of parts of our human eye is what, iris, which is around a black hole, around a black hole. So that part is iris, and cornea is the first transparent layer. Now next is a pupil. Pupil. Optic nerve. This is where electrical signals will go. Blind spot. That's it. Care for eyes. Read. If you are reading, then read in a proper light. Uh, don't read anything in without a light. Of course, it will impact on your eyes. Your eyes can't miss for reading a lot of days without light. Then avoid looking directly at a bright at sunlight indirectly. Okay, avoid this type of mistakes. Eat a balanced diet rich in vitamin A. Whatever you are eating, just eat fast food. It is what telling you. Next, question answers. You have question answers which is in front of you. State the two laws of reflection. First law of reflection is that what, the angle of incidence, the angle of incidence will be equal to the angle of reflection ray. This is the first law of reflection. And second law of reflection will be what, will be what, mm, incidence ray, normal line, and reflected ray. All this will lie on same plane, on same plane. It can be rough surface, can be rough surface, can be plane, it doesn't matter. Now next is, what kind of image does a plane mirror form? So of course it provide a clear image, it provide a erect image, virtual, and if there are letters, so letters will be inverted, laterally inverted. It is type of image a plane mirror will provide, will form inside plane mirror. What is the dispersion of light? It is a splitting a light into a white light, not a light. Dispersion of light is it is a splitting. It is a it splits splits a white light into seven lights if devices prism by using prism by using prism. Clear. Fourth is, what is the function of a retina? Function of a retina is to form image. It provides what, electrical signals to our brain. It forms image on it. It will convert light into signals to our brain. Clear? That's it. That's it. We have understood. So we are done about the light. Standard was 8th. That's all.